Assalamualaikum. My name is Muhammad Izani bin Abdul Hadi. The title for my FYP is Measurement of Fabricated Dielectric Lens Antenna. For my FYP, I will be supervised under Prof. Yoshihide Yamada. I will begin my presentation with introduction of lens antenna. Lens antenna is a microwave antenna that focuses on radio wave by refraction. Lens antenna is designed to focus on the transmitted energy diverging in the space to a desired direction. It used the principle of the converging lens in order to focus the energy transmitted on it. The most common configuration of the lens antenna consists of a feed and also the flat lens. Example application of lens antenna is at 5G mobile base station. Lens antenna is used at 5G mobile base station due to its multi-beam characteristic and also having a high gain value. Besides that, it is also lightweight and compact, which make it easier to be installed at mobile base stations. For the first problem statement, what multi-beam characteristic can be achieved? The main concern is to obtain a symmetrical beam shade when changing the position of the feed horn. Next problem is how to measure multi-beam radiation pattern of a fabricated lens antenna. The major problem when measuring the lens is the technical error from external disturbance, which will affect the result obtained. Objectives of this research are to study the multi-beam characteristic of fabricated lens antenna, to study the measurement software antenna measurement facility, and to achieve radiation pattern measurement of the fabricated lens antenna. For the first paper, the research shows how the lens was designed in terms of lens shaping. Lens design equations are also conditions of lens shaping. Based on the review paper, the lens comes with a feed horn which was implemented at the focal point. The content of the paper includes the lens design equation, which is used to identify the parameter of the lens by using MATLAB software. For the second paper, the purpose of the study is to produce a multi-beam antenna that aligns with the standardization of International Telecommunication Union. The paper also includes the designation of 8x8 multimetric array antenna, which is used to control multi-beam coverage site. This is the methodology. Firstly, the basic principle of dielectric lens antenna need to be understood. The basic principle includes how the lens works, the fundamental equation, and the multi-beam characteristic of the lens. For step 2, the measurement software used in the antenna lab need to be studied too. This is to understand how the setup in the lab was done. For step 3, the preparation of the measurement setup of the fabricated lens antenna. Preparation is made in order to do the initial test to make sure that the system works well. After the measurement setup is done, the last step can be done. The last step is to conduct the measurement of the lens antenna in an accurate chamber. The next part is preliminary work and expected outcome. First of all, antenna parameter study must be made in order to find the measurement distance in an accurate chamber, antenna gain, and the beam width. It is important to calculate the antenna parameter before the measurement started in order to set the measurement distance between the transmitter and the lens antenna. Since the expected beam width and antenna gain is already calculated, the expected outcome for multi-beam characteristic of lens antenna can be determined. So, this is the conclusion for my FYP. For FYP1, it is about the study of fabricated lens antenna and how to measure the lens antenna performance. Lens antenna can be measured in an accurate chamber by using transmitter, signal analyzer, signal generator, and rotating system. Multi-beam can be achieved by using lens antenna. Next is for FYP2. The fabricated lens antenna will be measured in antenna lab. The multi-beam characteristic of the dielectric lens antenna will be measured and the radiation pattern achieved by the lens antenna is recorded. I think that's all for my FYP1 presentation. Thank you for watching my video.